Hi guys, so here is part 3 of the step-by-step GPU fault finding guide. As I mentioned on the previous parts, and I'll say again on this one, this is a process that you need to do in order. So you need to do all the tests in part 1 and part 2 before you come to these tests in part 3. There's no point skipping those other tests because you may have already found out what the problem is with the graphics card. In part 3, we're going to look much more in depth to the voltage supplies we found on the graphics card, and in particular where we're likely to find short circuits or problems with those voltage rails and what that means, what the results of those tests mean for our graphics card. So no more waffle, let's get straight on with part 3 and I'll see you all again at the end. It's important that we understand what type of short circuits we're likely to find on a graphics card, so let's just again go to the pen and paper and we'll look at that. So as I mentioned, our graphics card has 12 volts coming in and 3.3 volts coming in. That's the only input voltage to the card. And you could see when I was probing around those GPUs, I was looking at the inductor coils. Now, the reason for that is that almost all the other voltage rails will be developed from one of these inductor coils, and the circuit on each one will basically be the same. So what we actually have is we have the 12 volts which goes to all of these circuits. The circuit itself is called a buck converter. Actually, technically it's a synchronous converter, but most people call this circuit a buck converter. And we also have them where there are many phases. I'll just show this. Another word used, or rather initials if you like, for this is VRM, which is voltage regulator module. But they all work basically the same. Without going very technical, we have two MOSFETs like this, wired in series, and going to ground. This is the symbol for ground, okay? This is the 12 volts. And the two MOSFETs connect to a coil. These are the inductors I was measuring from to ground, and the inductor generates the output voltage out. There's a little controller chip connecting to the gates, and it switches these on and off rapidly, one and the other. And basically the ratio of time that the top one is switched on compared to the bottom one that's switched on sets the output voltage. If this one is on more than this one, you get more out. If this one's on more than this one, this being connected to ground, you get less out. That's the basic principle of how it works. These go to a controller. I'll just draw it on one. And this is your VRM controller, sometimes called a PWM, pulse width modulator. Now that is a chip that may be driving one regulator like this, or it may be driving more. So you can have the same chip driving 2 or 3 different voltage rails. Each one of these outs is a voltage rail, okay? So let's just look at the voltage rails we have and what all this means. So as we mentioned before, and I'll put them in no particular order, we'll have PEX, which is about 0.9 volts. And then I'll just draw the first part of the circuit so it actually fits on the page, yeah. So we'll have another couple of MOSFETs here, exactly same thing. I won't bother draw the rest of it, I'm sure you can see what I mean. Okay, to ground, and another coil. This will be another voltage rail. So another one we have is VRAM. This is the voltage to the RAM, which will depend on whether you have GDDR4 or 5 or 6 or whatever generation, depending on the age of your graphics card. Older ones would have 1.8 or 1.5 or something else, but on modern cards this will be 1.35 volts. Okay, and we have another one. I hope I can fit them all on here. Okay. This is the supply to the memory controller. This is a similar voltage to this one. And on older generations of RAM, we probably don't have it. It's probably using just this voltage, okay? But this is the mem control, okay? And it's about the same sort of voltage. What else do we have? Well, we have the supply that's driving the circuitry to the HDMI or DVI or similar. Again, maybe not on all graphics cards, it depends on the architecture of the card. I'll just call this HDMI. Okay, and this is going to be usually about 0.75 of a volt. Again, some cards don't need it, it depends on what voltage the GPU is running at. And we have the voltage to the core, okay? So the core of the GPU, this is what draws the most power. That's why it reads the lowest resistance. Okay, and this one we'll have a number of these in parallel usually. So coil, V core, yeah. And quite often with this one you'll have 2, 4, 6, 8, whatever in parallel. We saw on one of our cards we had 4 of them. So in parallel, what it actually means is you'll have another pair of MOSFETs, okay, to ground, and I'll draw the coil coming this way this time, it doesn't matter. And that's also driving there, so we've got 1, 2 phases, and we may have more than that, okay. These phases, by the way, they don't run in parallel, so it's not that like both these switch on and then both these. It effectively uses one first and then the other, and then if we have a third and a fourth. This is like the rotating barrel on like a Gatling gun, you know, with the old machine guns. When in the 1800s they turned the handles and the barrels rotated, and it was done so the bullets firing down each barrel didn't effectively melt the barrel. So as the bullet goes down the barrel gets hot, but you switch to another barrel and fire a bullet, and switch to another barrel and fire a bullet, and after say 6 barrels you come back to the first one, or however many there are, and that one's cooled down enough now so you can fire another bullet. So that's why these are like this, and this is called a multi-phase VRM, okay. I've made some very detailed videos about how it works, but for just an introduction, this is enough, guys, yeah. As well as the memory control, the RAM, the PEX, or PCI Express if you like, the V-core, the voltage driving the video output circuitry. You'll have a couple others as well. So you've got a 5 volt, okay. Now the 5 volt doesn't generally use one of these because it doesn't have much power. This just uses a little voltage regulator, and we saw it on our examples. A little 3-pin voltage regulator, in, ground, out, and we had coming in 12 volts, and we had going out 5 volts. Okay, the 3.3 volt is coming directly from the PCIe connector. The 12 volt is on the PCIe. So this circuit doesn't use the coils like this. This is what's called a linear regulator. It has another name later, often called an LDO, which is a low dropout linear regulator basically. And the reason we can use something like this is because the 5 volt isn't actually powering much, and this goes into the logic circuitry. These are other parts of the board, integrated circuits, transistors. We'll look at them later, so don't worry about them now. We will look at them, okay? So that's usually a linear regulator. And the one other voltage we have is the 1.8 volts. Now, the 1.8 volts usually uses one of these again. Quite often it's a little 8-pin chip, but again, don't worry guys, we will look at them. We'll try and find them when we measure some voltages. And this normally has either the 5 volt or the 3.3 volt coming in, 3.3 volts, or possibly the 5 volts. It can be running from either of these, and out is the 1.8, which goes again to the logic circuitry and also into, quite often, the BIOS chip. The BIOS chip could be running directly from the 3.3, it could be running from here. Again, depending on what type of BIOS chip. More modern graphics cards will have 1.8 BIOS chips, older ones will have 3.3. And if you find a really old one, it'll probably be 5. So those are the voltage rails we have. Now, let's have a look at where we can find shorts and what they mean if we do. By what they mean is what is the damage that's likely to have been caused. So the worst possible scenario that you're likely to find is that you have a short from the 12 volts coming in to ground. If you find that, there are two likely causes of it. Okay, one, on here there are capacitors. We'll look at some of them when we look at the graphics card. Again, this is the ground symbol. These could be short circuit. There's also, from all of these voltage rails, there's capacitors on all of them and lots of them to ground, and one of those could be short circuit. This is the capacitor symbol if you're not that familiar with electronics. Okay, so we could have short circuits like that. If these have failed, then we just get a short. But if the short is in the capacitor here that's causing this to read short, then this MOSFET must also be short, because there has to be a path. 12 volts through the shorted MOSFET, through the coil, through the shorted capacitor to ground. Okay? These MOSFETs, by the way, are called high side, and these are called low side. High side because it connects to the high voltage, or high-ish 12, low side because it connects to ground. If you read a short from here to ground, it's a bad thing, yeah? Quite possibly what you're actually reading is a short in one or more of these MOSFETs and a short in whatever it is powering, okay? What do they power? RAM. Well, that's RAM. Memory controller. This is part of the GPU. The HDMI circuitry and output. This is part of the GPU. VCore. This is the GPU. Okay. The logic circuitry. This is just chips all over the board. Could be anywhere. Chips and transistors. 1.8 volt. Logic circuitry and BIOS. Okay. But the BIOS has to be read by the GPU. So as well as powering the BIOS chip, it powers the GPU, or a segment of it. The same with PEX. PEX is the interface between the GPU and the PCIe connector, and again, this goes to the GPU. Okay, so if we see a short from here, then we're going to have at least one of these short on one regulator, and there may be multiples on the same regulator, and we're probably going to have a short on whatever's being powered. Why? Because this RAM wants 1.35 volts. When this went short for an instance until maybe the fuse blew or something else gave up, it's now got 12 volts. It doesn't like it. It doesn't like 12 volts, even for like milliseconds, yeah? So that's why if you get a short from the 12 volts, you've probably got MOSFET shorted and the device it's driving. So you've likely got short circuit RAM, short circuit GPU. If you're really lucky, you've got some short circuit capacitor somewhere. Yeah, but as if you're lucky. Another scenario that you're going to find. The 12 volts reads fine. No short on the 12 volts. That's okay. Yeah. But when we measure it from these coils to ground, on one or more of them we find a short. Okay. So for example, RAM could read short. 0 ohms. Yeah. the GPU memory control could read okay, let's say 25 ohms. I mean, just rough figures, yeah. HDMI, this could read like 5 kilo ohms, it's fine, yeah. VCore could be reading like 0.4 ohms because it reads low, okay. This 1.8 volts doesn't drive much, so it probably reads in the several kilo ohms again, okay. This one rarely fails, to be quite honest. I'm not too worried about it. But look what the devices are: GPU, RAM, GPU, BIOS, GPU, yeah. So a short on any one of these probably means you've got damage. For example, if the RAM reads short, you can be fairly confident that even if you take all the RAM chips off and you change them, or you change the short circuit ones, you'll still have a graphics card that doesn't work, because having short circuit in the RAM, which is connected directly to the GPU memory control, you've probably got damage here as well. So you can see short circuits on graphics cards are very bad things, okay? If, by the way, you find a graphics card that reads short on the 1.8, yeah, and short on the PEX, but everything else reads okay, the chances are you've got a faulty GPU, because PEX goes to the GPU, 1.8 goes to the GPU, and most likely only one component is faulty, yeah, not like a short circuit and a BIOS chip in a short circuit somewhere else, and PEX doesn't really go anywhere else, yeah. So that's another one to look for, okay. I'll give you the last one to look for. You read on the 12 volts and you don't read a short, but you read some low resistance, okay. Let's say from here to ground you read 12 ohms. It's low. It's not short, but it's low. If you want to know where the short is, what you need to do is go from each of the coils to ground and measure the resistance. Now, quite likely PEX will read about 12 ohms. Yeah. RAM could be anywhere like 40 to 130, something like that, maybe 30 to 130, maybe outside of that range ohms. GPU about 0.4 up to maybe a couple of ohms or so, depends on the GPU. This reads high, I've told you this, maybe in the kilo ohms. This will be in the kilo ohms. So if you're reading a lowish resistance from here, if you measure from the coils, find the one that reads the same resistance to ground from here, either end, that you read from here, 12 volts. And that will tell you which one of the MOSFETs is short. Yeah. Another scenario well worth mentioning is that you'll have the 12 volts reads fine. Yeah, so this reads into the kilo ohms or even very high into the mega ohms. And by the way, when you check the 12 volts, always check on the 6 or 8 way connectors on the top edge of the graphics card, and also check on the fingers of the PCI connector, because you can quite often find that, for example, the VCore, this is coming from the connectors on the graphics card, 6, 8 pin, these sort of things you find on the top of the graphics card. But the RAM, for example, may be coming from the 12 volts on the PCIe connector, okay? So you can find a situation where this is running one of these buck regulators or converters, and those are running another. You can have situations where you may have 8 of these phases, and 4 of them run off one connector and 4 run off the other connector, and so on. And I've also seen situations where there's multiple phases here, and say 4 of them run from here and 2 run from here, and this sort of thing. So always when you're looking for shorts on the 12 volts, have a look both on the PCIe connector and on the 6, 8 way connectors on the graphics card, okay? One last thing I'll mention then is that you have this situation where we have a high resistance on 12 volts, Okay, both there and there. Okay, but you have a short on one of these voltage rails. Okay, if you find that, then because you have this high resistance on the 12 volts, you can say basically all these high side MOSFETs are okay, or they've got open circuit, or the fuse has got open circuit in there as well. Yeah, bear in mind there'll be a fuse in this circuit here somewhere coming in, and also from here there may well be a fuse. But assuming the fuses are okay, you can measure the 12 volts back to the PCIe, you can measure 12 volts back to these connectors. If these are reading very high resistance or rather high, kilo ohms, mega ohms, this sort of thing, and you have a short on one of these, one of two things is wrong really. You've either got a short in the low side MOSFET, the one that's connecting to ground, on whichever rail, or you've got shorted capacitors on whatever the rail is powering, or you've got a shorted device, like for example short circuit RAM, on whatever that rail is powering. Now, I won't go into diagnosis of faults and VRMs in this video. This video is more to help you pin down where the problem is and then zoom in on that area to diagnose further and hopefully fix it. So I've made several videos on short circuit finding and VRMs, and I'll link them in the description to this one. So if you have a problem in that area with shorts, have a look at those videos for more information. Just to finish this video then, let's have a look at a faulty graphics card and take some resistance readings. Okay, so here is our GTX 1080 Ti, which we know has a bubbled GPU. We looked at it, so we know this is faulty, and that is faulty. Just out of interest, by the way, that is not a missing RAM chip. It's not been stolen or used for some other repair. On the 1080 Ti's, you always had 11 chips. That one isn't fitted, and it's not always there. It could be somewhere else that isn't fitted. Okay, and you'll sometimes find this on other graphics cards where you have, for example, 8 places but only 4 RAM chips fitted. This is because that graphics card was available in a 4 gig and an 8 gig version, for example, so they use the same PCB and just put less chips on the 4 gig version. So don't be surprised to find that sort of thing on graphics cards. Anyway, back to the point. What do the resistances read like on this one? Well, let's do the same methodical method. So first of all, the first 3 pins is 12 volts. And that reads in the kilo ohms, so there's no short there, okay? Fourth one in for me is a 3.3, 1, 2, 3, pin 4. Again, it reads 32 kilo ohms, it's in the kilo ohms, there's no short there. Is there any fuses down here? This looks like it might be a fuse. And it reads short as you expect. We also have the 12 volts coming in here. What do we see? Well, that reads kilo ohms. Again, it's the kilo ohms. So there's no short here. Also, if we read something like kilo ohms, it pretty much tells us the fuse must be okay. Otherwise, we would read open circuit. Fuse is okay. So the fuse is fine on this. Now let's look at the voltage rails. So what do we have? We have one here, probably PEX because it's near to the PCIe connector. We have a whole row of them here, 12 on this. These quite likely are all for the V-Core because it's a very power hungry GPU. This is your Gatling gun I mentioned, your multiple phases, all on the same voltage rail. 2 here, quite hefty ones, quite probably RAM, or one's RAM and one's memory controller. The one here isn't located near any of these MOSFETs, so this is probably a filter. Okay, that one probably a filter as well. There's probably one on each of these. And we have a few more down here. So let's have a look and see if we can find what we have. So we'll start with the V-Core. That'll be these. Is our GPU reading short? Well, it reads 0.5. I put my meter into the lower resistance range and I've just zeroed it. So it's now zeroed, yeah. It's not in diode mode, it's in resistance mode. What have I got? Well, that actually reads less than 0. I mean, I probably had a better connection actually. Zero it again. Calibrate. 0. That is short. That is 0. Yeah, that's not like 0.2 or 0.4. This is reading short on the V-core. And all these are going to V-core. So we know straight away we have a short on that V-core rail, okay? Now I mentioned there's lots of capacitors on this voltage rail because of a short circuit capacitor. And we might think, oh well, we might get lucky. Okay. Let's look at these. This is the memory controller. Well, that's climbing up 75 ohms. That's probably the RAM. If this reads the same, yeah, they read basically the same. So these two will be working together, and this is the RAM supply. What else do we have? That reads high. That reads high. I'll just go up into the higher resistance range. Have a look. Yeah, that reads high. That reads high. So there's no shorts here. Points like 720 ohms, 728 ohms. That is probably a voltage rail, maybe the 1.8, something like that, most likely. That reads high. That one reads short. Okay, so whatever this is, and this looks like a driver chip next to it. You see there the driver chip. This is a driver chip. That one reads short. So we have another short circuit voltage rail here. I'm back on the normal resistance range, so my meter isn't quite zeroing, Luke. This we thought as PEX. That reads short again. So on this graphics card, we know we have short circuit V-core. Where does it go to? The GPU. We have short circuit PEX. Where does it go to? The GPU. And we have a short circuit on this one here as well. Quite probably the 1.8. It's going to be one of the other voltages, yeah. Maybe this one is the memory controller because these both seem to connect together as RAM. But there's a short circuit on it, and I think we can say confidently that goes to the GPU. So all this, as well as the fact that this is bubbled, all these readings are telling us we have a faulty GPU. Even if it visibly looked okay, we have a faulty GPU. We do not have short circuit capacitors on here. Oh, and by chance there's another short circuit capacitor on this rail, and hey, guess what, we're really unlucky because there's another short circuit on this rail on a capacitor. No, we have a short circuit GPU, the common thing. Okay, so that is what to look out for when measuring resistances. So that's as much as we can do with visual checks and resistance checks. So what have we learned? Well, we know none of the cards have a short circuit on the GPU or on the RAM or any of the other power rails. We know there's no shorts there. We know the smaller cards, these RX cards, looks like the RAM has been working very hard because of this oily kind of loop. Probably X mining cards. And we also know that the resistances to the GPU are different between these two, okay? So there's a possibility we have one or both faulty GPUs here, but it's just a possibility. And this one, I don't see anything obvious, but I don't have one to compare with, but I don't see anything wrong. So the next thing then, guys, is we're gonna power these cards up next and have a look to see what voltages we can see. That will determine definitely which voltage rail is which. And if any voltages are missing, we'll know straight away we have a problem in that part of the circuitry. So guys, there we are. I hope you enjoyed that in-depth look on paper. As I mentioned, this guide is to help you figure out where the fault is. I'll link from the description to this video to more videos I've made specifically about short circuit tracing on graphics cards in VRMs. So if you've identified now you have a short circuit somewhere, please refer to those videos, and that should take you further down the path to knowing what the problem is and whether it can be repaired. In part 4, I'm sure you'll be interested to know, we're now going to power some of these graphics cards up, and we're going to have a look at the voltage supplies and see what help that also gives us in diagnosing the fault on our graphics card if we haven't found a fault so far. Enough said then, so I look forward to seeing you soon on part 4. Ciao for now.